Hello, today we will be discussing descriptive statistics. Um, Question one is regarding outlier identification and handling. So I used a file from Kaggle of the top 25 NBA players and their playoff careers. So I brought that data in and did some descriptive statistics just to see how the data was looking statistically. We can see the mean at 43, 4,310, and the median is at 3,897. So immediately we know there is some variability within the data set. Also, with that standard deviation being over 1,100, that also indicates that there is some variability and the data may be skewed in this data set of total points. We are looking at total points right now. So to get a visual of it, I use the scatter plot and looking at total points, we see there's a clear outlier here around 8,000. We're looking at total points for each player. So someone is an overachiever here. I use the Z method to get the Z score and check for outliers. I set the threshold at 3, and the outlier return was in array 0. Array 0 has a Z-score of 3.28, so it is outside or greater than the Z-score. So that would be our outlier for using the Z-score. We return or locate the particular array, and it happens to be LeBron James with 8,023 total points for his playoff games. I then look at the IQR method as well. Well, I pulled in all of the players because I just wanted to see and make sure that that was the outlier, and it is. And here's all the other 25 players. I also use the IQR method to get the lower and upper bounds and the range. And to find the outlier here, once we found the outlier and returned it, it indeed brought back LeBron James with 8,023 points. So I went ahead and removed that outlier, and I printed out the original descriptive statistics as well as the clean statistics. So you can see here the count is 24 for the clean. The original is at 25, so we did remove that outlier. The mean came down some. The standard deviation decreased greatly. So removing some of that variability within the data set as well. As we go on to question 2, discussing bias and confounding variables. Skewed data can be an indicator of bias within a data set. A significant difference in the mean and the median is evidence that outliers are present, and that can be the cause of the skewed data. Depending on whether the mean is closer to the median on the left or the right will determine which way it is skewed. And also bias can happen from incomplete data or missing values as well. I went ahead and checked for missing values within the NBA playoffs data frame, and it looks as though there are some no values being returned in the Hall of Fame column. So, question 3, we talk about handling those missing data points. So, I went ahead and pulled those players and Hall of Fame to see just who was missing Hall of Fame data. And it just so happens to be LeBron James, Kevin Durant, Stephon Curry, and James Harden. And if you know anything about the NBA, these players are still active players, so they have not been inducted into the Hall of Fame yet. The Hall of Fame looks to be the year that they were inducted. So instead of leaving those as no values, one of the ways that you can handle missing values is either remove it completely or replace the value with the null with another value. So I chose, since these are floating numbers, I chose to replace the null values with 0. Using my formula, put in 0.0, and now as you can see, LeBron James has 0, Kevin Durant, Stephon Curry, as well as James Harden. all have zeros for their Hall of Fame year because they have not yet been inducted. As we move on to question number 4, analysis of mean and median values. As I stated, mean and median, if there is a discrepancy or difference between the two, that means that there is probably an outlier that's causing the mean to steer one way or the other away from the median. As we look at 3-point goals made, we have the mean at 132, but the median is substantially lower at 51. So with 132 being the mean above the median, that means that there's going to be an extreme outlier on the right-hand side or the upper bound. As we look at the box plot, it does show that there is an extreme outlier here with someone making well over 600 3-point field goals. I use the IQR method to get that interquartile bound and find the outlier. Once we find the outlier and get it to return the outlier, it returns Steph Curry with 618 3-pointers made. I remove him from the data set as well, and the mean of the original data was 132. It is now 112, and the standard deviation dropped as well. And the mean and the median did drop, so that does seem to be that there could be a couple of more outliers that are just not extreme outliers, but they have higher values. Looking at the data visualization for question number 5, I chose to use a box plot and looking at the total games played in playoff games. Here we see that players on average have appeared in between 160 to 210 games. The median value of the IQR is slightly closer to the first quartile, which indicates the data is skewed on the right side, and there is an apparent extreme outlier here with someone playing in over 280 games. That's someone pretty sure that's LeBron James, and we can actually go up here and verify that as well. Here's LeBron James playing in 282 total games. As we continue to move through the assignment, question number 6 is based on measures of central tendency and variability. So this time I use a different data set. This is the Basketball Olympics data set. So this is based on the points scored by the winners of those basketball games throughout history. So again, we're looking at winner points. So I calculated the mode, the range, the variance, as well as the interquartile range and the descriptive statistics. So looking at winner points, the mean is 80, the median is 83, standard deviation is 22, the mode is 89, meaning the number of times that the winning team has won, the score has been at most of the times 89. So looking at this data, what we can see is the average score of the winning team is 80.75 points. And again, the mean is less than the median. The median is 83. This is indicating bias in the variable. And since the mean is below the median, the data is skewed to the left as well. I decided to use a box plot to show that there actually is some extreme outliers here on the left side, as I first stated, based on the mean and the median difference. Question number 7 is about data cleaning, and I put in a different set of data this time. This is cafe sales. So I pulled in the descriptive statistics or read the descriptive statistics, but it's not the same as general. Generally, we see the mean, the mean, the median, standard deviation, things of that nature. Well, it only pulled in the count, the unique count, the top performing or featured um, data point, and the frequency of that data point for each column. So in that, I can see that transaction date pullback unknowns, that's the most frequently viewed data point in there because the transaction date differs so much. So there are more unknowns than the same transaction date. But I checked to see if there were no's within each column, and there were no's in most of the columns, some of them over 3,000 no's in the column. So I did a preview of the data to see how it looked, what I was working with. Here you can see how it came out. There were some no values, there were some errors, there were some unknowns. So in each of those columns, I looked for the unique values. Here it was the categories of the type of things that were sold. So those errors and unknowns, I replaced them with just an unknown. As well as for quantity, I replaced, because this is well, it will be an integer, I replaced them with zeros. And one of the things I do want to call out before I keep going forward is that although these were numbers, they are not listed as integers or floating types. So we will be addressing that later in this question. But I went ahead and instead of leaving it as error and unknown, I replaced them with zeros to match the type of data that is in there currently, as you can see here. And I continue to do that, replacing those values, those errors, those unknowns, those null values as well to match the data that is already in there. And I did it for each column. And with the dates, I also did that as well. But this particular time, I replaced it with zeros. So as I check back for null values, now you see that there are no nulls left within that data frame. Now I go on to define those types, and I put the transaction ID as a string because it has numbers and letters. The item, I made it a category because there were only, I think, 10 items that you could choose from. Made the quantity an integer. The price per unit is a floating number, as well as total spent. I made the payment method a string, and the location, it was either in or takeout or unknown. So I made that a category as well. And that transaction, I changed it to a date and time. So now you can see everything has been assigned to its appropriate data type. I searched for duplicate rows, however, they return no duplicate rows. So now as I use the descriptive statistics function, now we can see some of those statistics and quantitative values. Lastly, question 8 was about a group analysis. And here we'll use the clean data to analyze based on the type of item purchased compared to the total amount spent. So we use the total spent by item, and we group by the item, and we're looking at the total spent. So we get the descriptive statistics here. And as we can see, the cafe sold more juice based on just the volume. But if we look on the mean of the total spent, the average spent, the most was spent on salads. As we look at this plotted, we can see here there might be a slight skew for a couple of these, such as cake and salad, maybe juice, just because you can see that it's not necessarily centered. The mean is a little closer to one, the upper bound compared to the lower bound. So there may be a little variability here, but overall, there's no really extreme outliers. There's here in the unknown, there's one, but we're looking at it by item. And so we don't know the item, so we're not focused on that particular outlier. Thank you very much for your time.